Assalamualaikum. Hi guys. In this video, I'm going to show and calculate with you the empirical formula based on percentage composition by mass. So we have example 8 where I have ascorbic acid, vitamin C, which cures scurvy and may help prevent the common cold. This is only the introduction. But the real information is starting from the second sentence. It is composed of 40.92% of carbon, and you have the percentage of hydrogen, and last but not least the percentage of oxygen. So you know what is your element that you should put in the Marmora table. Next, the molar mass of ascorbic acid is 176 gram per mole. Here is the trick. If you got the value for the molar mass in your question, it means that you have to determine its molecular formula. So first, when you do the solution, this is very important for you to start. Before constructing the Marmora table, you have to write down a sentence or a statement, which is assume the mass of ascorbic acid is 100 gram. So this is very important because you are going to use Marmora table, which the first row is mass in units of gram. But the information is given in percentage by mass. That's why the statement here at the top here is very important. So please be careful when you answering this second method for determining the empirical formula. Now let's continue with the table. I have right now the value for carbon, hydrogen and oxygen. I put it in alphabetical order or which one mentioned first. So we have the value here. And the next one you are going to calculate the moles. So each of them you can have a go. So moles of carbon will be 3.41. Hydrogen is just 4.58. It's fine if you want to show it or not. And last but not least, for oxygen, 3.41. So here you can see that the smallest value of moles will be 3.41. So I'm going to show my calculation. So how you want to put the whole number as your empirical formula? Especially for this part, it's very tricky. You cannot round off straight away as 1. It is wrong. So what you have to do, you have to choose the value by multiplying with a factor. Usually when you want to choose which one is the factor number, we will use times 2 first. So I'm going to determine this one as my whole number. If I calculate 1.33 times 2, I will have 2.66. It's quite far to round off as 3. So that's why we cannot choose factor number 2. I'm going to choose 1.33 times 3. So if I choose that one, I will have my value, which should be 3.99. So this one is the most suitable one. So I'm going to multiply all of them with 3. And I will have the value 3 here. And here is 4. And here is 3. What you have to take a look here, the difference should be plus minus 0.01 between your whole number that you got with the value that you calculate by multiplying with factor number. I'm going to explain a bit more about this later on. So now we have the whole number for your empirical formula for each of the element. So you can write down your empirical formula, which will be your lower subscript of each element. This is going to be C3H4O3. And now you've done for empirical formula. Don't forget you have to show for molecular formula. So I'm going to continue. Empirical formula that I got here is this one. So I have to determine the N value first. N equals to molar mass over empirical formula mass. So this is where I'm going to calculate this one based on the empirical formula. For the molar mass, it's given in the question 176 and then over 88. So you will get 2 as the value for n. So how do I get 88 here? This is because I calculate the mass of all atoms in my empirical formula. So I will have 88 here. And next, I'm going to determine my n value. So now I put the n value here to determine the molecular formula. So I will have my molecular formula, which will be C6H8O6. So this is how you answer example 8 based on percentage composition by mass. Now, I want you to take note a bit about the value which is in decimal places. When you calculate the simplest ratio, sometimes you will have a value with decimal places. But please, you must never round off value which close to whole number. But instead, you have to multiply the value by a factor until you got the whole number. And that value must be close to whole number by difference plus minus 0.01. So how can you understand more about this? Let's take this one as example. Take note that when you get to this point, for example, I got 0.25. This is 1 over 4. So in order for you to get the correct value, you times by 4, you will have 1 as your whole number. Next one. For example, I got 0.33. So 0.33, if I times by 3, I will have 0.99. So this is close to 1. So you can run off because the difference is plus minus 0.01. Same goes for 0.5. If you want to get the whole number, you times by 2, you will have 1. So you got the whole number. Last but not least, maybe I put 0.75. So to get the whole number, you have to multiply by 4. So you will have 3 as the whole number. So this is how you want to determine whether you have to multiply by a factor or not. And please try and error and choose the lowest one first, times 2, times 3, and so on. Then you will see the difference. If you got the correct requirement, you can choose that one as the whole number. So that's it for this video. I'll see you in the next one. Bye!